Okay, in today's video, we are going to be talking about properties as well as dividing with zero. So we are starting on page 101 and first looking at the commutative and associative property. So it says, on Monday, Jerry found 5 cans to recycle. On Tuesday, he found 3 cans to recycle. His friend Julie found 3 cans to recycle on Monday and 5 on Tuesday. Who found more cans altogether? So if we draw a picture to show what is happening, so Jerry on Monday found 5. And on Tuesday he found 3. So he found 5 plus 3 more, so he found a total of 8. Whereas Julie found 3 on Monday and then 5 on Tuesday. So she is doing 3 plus 5, which also equals 8. So it says write the number equation that shows the result. So you should notice for Jerry, he is doing 5 and then acquiring 3 more. And that gives you the same result as Julie, who started with 3 and then increased by 5. So then it just says replace 5 with an A and 3 with a B and show the equation. So this is an example of the commutative property, saying that if you take a number and add a number to it, that is the same thing as starting with the second number and then adding the first one back on. So this is commutative. So we can add in any order. Okay. In example number 2, it says Jack had carried 4 pails of water down the hill on Monday morning, and then he carried 3 pails of water down on Monday night. On Tuesday, he carried 2 pails of water. Jill had carried 4 pails of water down the hill on Monday, and then on Tuesday morning, she carried 3 pails of water down the hill, and Tuesday evening, she carried 2. Who carried more water pails down the hill by the end of Tuesday? So again, what did Jack do? So Jack carried 4 on Monday morning and 3 at night. And then on Tuesday, he carried 2 pails. So that's 9 total pails of water. Jill carried 4 on Monday, and then she made 2 trips on Tuesday, where she did 3 and then 2. Okay, so if you check, so for Jack, we're doing 7 plus 2, which is 9. And for Jill, we're doing 4 plus 5, which is also 9. Okay, so these properties are the same. So if the commutative property, this is an example of the associative property, which is an extension of the commutative property. So not only can we just add 2 numbers in any order, we can actually add 3 numbers in any order. So we can do A plus B first, then add in a C, and that will give us the same result as if we add our B and C, our second and third numbers, and then add the A, the first number. So this is associative when you can change the grouping of the numbers. Okay. So this works for addition. It also works for multiplication. So if we move on to the next page, let's see. It says there are 2 kinds of candy boxes on a shelf. So A says one candy box has 3 rows of 2 candies in each row. Draw a picture. So if it has 3 rows of 2 candies per row, writing a number sentence. So we have 3 groups of 2 in each group. So that's 6. And then it says the second candy box has 2 rows of 3 candies in each row. So we have another box. This time it has 2 rows with 3 candies apiece. So there's the picture. Write a number sentence that shows this result. So this is 2 groups of 3, which is also 6. So it says replace the 3 with an A and 2 with the B to show the equation. So this just tells us that if we're looking for an answer, A times B is going to give you the same result as B times A. So we can multiply in any order. Okay, so that is also the commutative property of multiplication this time instead of addition like we previously did. Okay, and then one final example. Again, just an extension on the commutative property like we did before. It says one brand of colored pencils comes 8 pencils in a box, 12 boxes in a crate. How many pencils do I have if I buy 5 crates? So if it's 8 pencils a box, 12 boxes in a crate, what if you bought 5 crates? So if we do this and multiply the numbers in the order they appear, this might be a little challenging. So 80 times 12, well, 80 times 10 would be, or 8 times 10 would be 80. And then 8 times 2 would be 16. So that's going to be 96 times 5. Oh boy. And then 96 times 5. Let's see. 90 times 5 would be 450. And then 6 times 5 is 30. So 450 plus 30 should be 480. Okay. So the next question says, would it be easier to multiply the numbers in a different order? So what if we could do instead 8 times 12 times 5? So this is going to be a lot easier for kids to do. So 12 times 5, 5 times 10 would be 50 plus 5 times 2 would be 10, so that's 60. And 8 times 60, well, if 8 times 6 is 48, add the 0, that's also 480. Okay, so again, this just tells us we can multiply in any order. So we can take the first two numbers times a third, and that gives us the same result as if we take the latter two numbers, multiply, and then multiply it by the first. So this is the associative property for multiplication. Okay, so commutative and associative. All right, then on the next page, it says we are exploring the distributive property. So this says use graph paper to show an array for 5 by 7, and then now show the array for 5 times 7 can be separated to show 5 times 3 plus 4. So we have graph paper on the next page, on page 107. So it just wants us to show that we can do 5 times 7. So I'm going to try this with my highlighter here. So 5 by 7, so 1, 2, 6, 7. So we can find the area by doing 5 times 7, or we can do the distributive property, which we talked about a few videos ago in our algorithms, that I could break the 7 down into 3 by 4. So I can instead make this a little easier and do 5 by 3 combined with 5 by 4. So if we count, so let's see, this one is 5 by 7. So we have 5, 10, 15, 20, 25, 30, 35 little squares in here. And then this one is 5 by 3 plus 4. So if we break it down, 5 times 3, so 5, 10, 15 are right here. And 5 by 4, it's 5, 10, 15, 20. And then 15 and 20 add up to be 35. So if you wanted to make a simpler problem, you can. Okay. So it says, in your group, write 3 other expressions in the form 5 times something that are equivalent to 5 by 7 and sketch the array to justify. Okay, so what else could we possibly do? So what else adds up to be 7 besides 3 and 4? So we could do 1 plus 6. We could do, 2 plus 5. I'm going to relist 3 plus 4 again. And then since since addition is commutative, we can flip those around also. So we could write 5 times 4 plus 3, 5 times 5 plus 2, and 5 times 6 plus 1. Okay, so if we were to sketch these, so go back to our graph paper, 3, 4, 5. So we could be doing, our first one was 1 by 6. So 5, 1 by 6. So verified, this is 5, and then we'd have 5, 10, 15, 20, 25, 30 here. So that would be 35. And then the other one would be 2 by 5. So a 2 by 5 would look like that. So 5, 10 is here, and then this would be 5, 10, 15, 20, 25. So that also adds up to be 35. And then we already did the 3 by 4. The 4 by 3, it's going to look the same thing, just kind of flipped over. So if I did this, we would have the 4 by 3, the 6 by 1, and the 5 by 2. So I'm going to save a little time and not redraw those also. Okay, so what else is it asking us to do? Replace 5, 3, and 4 with variables and write an algebraic equation to show the property that is demonstrated. So it's just saying that you can take A times B plus C, which is the same thing as doing A times B plus A times C. Okay, so finding the area of each one of those, so using the distributive property and then adding them together, the two parts. Josie wants to find the answer for 7 times 13. Show 4 different ways Josie could solve the problem by using the distributive property. So what could you do? So anything that's going to add up to be 13. So probably the easiest would be something like 10 plus 3, because then we would be doing 7 by 10 plus 7 times 3. So that would be 70 plus 21, so 91. What else could you do? Any combination of this. So 1 with 12, 2 with 11. So maybe 2 with 11 sounds easy. So let's try that one. So we'd be 7 times 2, 7 times 11. 7 times 2 is 14, and 7 times 11 is 77. So 77 plus 14 is again 91. What else could you do? We did 3 and 10 already. So 4 and 9, 5 and 6. Oh, not 5 and 6. 5 and 6 would be 11. So 5 and 7. No. Oh, sorry. Maybe I should write these out because I'm confusing myself. So 3 with 10. So it'd have to be 4 with 9, 5 with 8, and 6 with 7. Okay. So those would be all of the combinations, plus the one I mentioned earlier, 1 with 12. So let's see what the rest of these might be. So let's see, 7 times 4 is 28, 7 times 9 would be 63, so 91. 7 times 5, and let's see, 7 times 5 is 35, 7 times 8 is 56, so that's 91. 7 times 6 and 7 times 7. So 7 times 6 is 42, and 7 times 7 is 49. So that makes 91. And then our last case would be 7 times 1 and and 7 times 12. So that's 7 and 70 plus 14, so 84, so 91. Okay, and then again, because of commutative property, you could flip these around. So you could have 12 plus 1, 7 plus 6, 8 plus 5, 9 plus 4, 11 plus 2, 3 plus 10. Okay, all right, so that is all in relation to properties. So now we're going to look at dividing by 0, which is on page 109 right here. So situations involving dividing by 0. So first of all, it says, write a word problem for 12 divided by 3, draw a picture to demonstrate the problem, and explain what the answer means. Okay, so you had to do this on your test recently. So writing a problem for 12 divided by 3, and to make it easy on ourselves, let's do a partition method, because we could do partition or measurement. So let's say I have 12 cookies. I want to give want to give 3 friends an equal amount of cookies. So the question would be, how many cookies does each friend get? Okay. All right, so a picture of this. So I would have my 3 friends. Let me put like little smiley faces on them because they're getting cookies. So I would pass out my 12 cookies. So I'd give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cookies out. Okay, and explain what the answer means. So the answer to this question would be that I got 4 cookies. Each friend got 4 cookies apiece. So the reason that I know this is because we justify doing division using multiplication facts. So if we think about 12 divided by 3 is something, what that really means is I have 3 groups of some size is equal to 12. So 3 groups, so 3 friends are getting how many cookies each, so that there are 12 total cookies. Okay, so this would be the multiplication problem. And we know that it's 4 because what is the only number, if I take 3 times what, has to give you 12. So the only number you can multiply by 3 to get 12 is 4. So that is how I can justify the answer is going to be 4, based off of this multiplication fact. Okay, so what if we change the situation? What if instead of doing 12 divided by 3, we now think about 0 divided by 3? So how would the word problem change from 12 divided by 3 to 0 divided by 3? So this would mean I have no cookies now. So my word problem would be I have 0 cookies, and I want to give 3 friends an equal amount of cookies. So how many cookies does each friend get? Okay. So let's think about this. So I have nothing, but I still have my 3 friends. But this time they're going to have sad faces because they're not getting any cookies at all. So we would just have a picture that looks like this. So think about what we're doing. 0 divided by 3 is something. So if we change that into a multiplication problem, we have our 3 friends are getting how many cookies each, so that we end up with no cookies at all. So what is the answer to 0 divided by 3? So what could this question mark be? 3 times what will give you a 0? So the only thing that is going to work is that is a 0. So the only number you can get, or sorry, you can multiply by 3 to get 0 is 0. Okay, so that is why 0 divided by 3 is going to be 0. Okay, and it's also true 0 divided by anything will always be 0. So we talked about this when we talked about our divisibility rules a few videos back. Okay. All right, so now flip this over. So page 110. So now, what if we wrote a problem, again, instead of 12 divided by 3, what if we now changed it to 12 divided by 0? So 12 divided by 0 would mean I have 12 cookies. So we're still thinking about in the partitive sense. So, but now I have 0 groups. So I have 0 friends to give cookies to. And then it gets a little, oh, sorry, give cookies to, just T-O, not T-O-O. So then the question would be, how many cookies would each friend get? Ooh, can't write today. Each friend get. Okay, so what would a picture look like? So a picture would just be my 12 cookies just hanging out, and then I would be sad because I have no friends to give my cookies to. All right, so this would be the case of 12 divided by 0 equals something. So if we change that into a multiplication problem, I would have 0 friends would get how many cookies each, so that they would all have a total of 12 cookies. Okay, so what number could go right here to fill in this blank? 0 times what makes 12? Well, nothing. That's impossible. So there is nothing that can make 0 times, I'm just going to restate this, equal 12. Okay, so nothing can go in that blank. So since this is impossible, we call this situation undefined. So 12 divided by 0 is undefined. It's impossible to do. So anything divided by 0 will always be undefined. Okay, so if it's 0 divided by something, it will be 0, but if it's the reverse, it's undefined. So then for fun, what about 0 divided by 0? Is there a solution to this? And if so, what is it? So what would a word problem look like for this? So this one gets a little weird. So this would be like, I have no cookies and no friends to give them to. So how many cookies will each friend get? So this is, like I said, a little weird. Okay. So is there a solution for this? So what generally happens is I have students tell me the answer is 0. So they say, you know, back here, you said that 0 divided by anything is always 0. So I could, you know, form a pattern. 0 divided by 3 is 0. 0 divided by 2 is 0. 0 divided by 1 is 0. So wouldn't 0 divided by 0 also be 0? That makes sense, right? On the other hand, if you know anything about division, usually anything divided by itself is always 1. So what about if I said 3 divided by 3 is 1, 2 divided by 2 is 1, 1 divided by 1 would be 1. So wouldn't it make sense that 0 divided by 0 would be 1? So what is the answer? So if we think about this multiplication problem, so we're doing 0 divided by 0 equals something. So if we do what we have been doing in the past, so this 0 tells us the groups. So there's 0 groups, 0 friends getting how many cookies each, so that we end up with no cookies total. Okay. So think about what number could go in this problem to make this statement true. 0 times what would give you 0? Well, it could be lots of things. It could be a 1, it could be a 2. 0 times 3 is 0. 0 times 4 would be 0. 0 times 100 would be 0. So actually we're both right when we say the answer is 0 or the answer is 1, because it could be almost anything. So anything could make 0 times something equals 0. So therefore we would call 0 divided by 0 what we call indeterminates. We don't know exactly what the answer is supposed to be because there are millions, infinity amount of answers. Okay. So there is no homework necessarily associated with properties or this divisibility with 0, but they will appear on an exam or the final exam or an upcoming quiz. So you do still have to know these even though you don't have anything else to practice. Thanks for watching.